Welcome to part 6 of your VISM tutorial. In part 5, we looked at adding vehicle inputs and desired speed points. Now in part 6, we are going to look at adding traffic lights and how to add a signal timing card to your intersection. So right now I have my intersection all drawn out on VISM. We're going to go to the top ribbon and click Signal Control. Under Signal Control, click Signal Controllers. Ooh, don't double click. Or you can. So after you click Signal Controllers, you will have this box pop up underneath your network editor. In this box, go to a blank space and right click. From here, the drop down menu, you can click Add, and you can add a signal controller. There's a lot of different types of signal controllers that you can add. You can choose what you want to do by going to Type and looking through them. In this example, and in your assignment, you will be changing a ring barrier controller. It's good to also name your controller. So I'm going to name it Ottawa and River. From here, you can click Edit Signal Groups. In the ring barrier controller editing box, which pops up, you can look at a lot of different things. And you can choose to look at them by checking the checks on the left column. But the only thing we will be looking at in this tutorial is the base timing. And within base timing, you can also check to see other things. So if I unchecked timing by SG, SG standing for signal group, the basic and advanced patterns would disappear. You could change this as required depending on how complicated you want things to get, but we are going to go over a very simple example that should help prepare you to do your assignment. So, first, you should label your signal group number. What this means is what movement is associated with which signal timing. In your assignment, you have a four-legged intersection that has Columbia Street going east-west and Westmount going north-south. According to the Federal Highway Association, their simulation practices is basically this, and this is commonly used in industry as well. So what this diagram means is your through movements are given a signal group that is an even number, and your left turns are given odd numbers if there are protected left turn signals. So if you haven't really done anything in traffic engineering or transportation engineering, or just signal timings in general, each phase of a signal timing is coordinated with the opposite one. So the eastbound greens will appear at the same time as the westbound greens. And after that, the northbound greens and the southbound greens will be on, while the eastbound and the westbound have red. Now, if you think about the times when you were trying to turn left, you sometimes got a protected green, meaning that the intersection that the traffic signal had four lights, and then they had an arrow at the bottom that indicated that you had the right of way to go first before the through movements. So more left turning people can go through. This is essentially what you're going to try to input into your signal timing card in VISM. So if we follow this convention where you will create signal timings or input the signal timings for each of the movements as numbered here, you can follow any signal timing card and get your signal timing done for VISM. So we're going to do a very simple example using a simplified numbering system, and we will go through that now. So first, let's number our signal groups. So in the Federal Highway Association, which is one of the governing bodies of traffic engineering practice, we will have it numbered 1 to 8. where even numbers are the through movements and the odd numbers are the protected left turns. Let's say that you were modeling an intersection with only through movements or through signal lights. You would only add signal groups 2, 4, 6, and 8. But because you have turns at Columbia and Westmount, also include the odd numbers. So let's get started. 1, 2, 4, 5, 5, 6, 7, 8. It is also a very good convention to add the signal group name. So essentially adding the name of what direction is going in. So according to the Federal Highway Administration, the first signal group is the northbound left turn. Number 2 is southbound through. You can also add a TH for through. Number 3 is left turn is a westbound left turn. Number 4 is eastbound. No, never oh, sorry. Number 3 is eastbound left turn. Number 4 is westbound through. Number 5 is southbound left turn. Number 6 is northbound through. Number 7 is westbound left turn. I haven't doubled it right. Is this? Yes. Yeah, and the last one, 8, is the eastbound through. Yeah. For this example, for our minimum green, we're going to have, for each of the left turn movements, they will have a minimum green time of 3 seconds. And the minimum green for the for the through movements is going to be 35. Vehicle extension, max 1. Yellow time. We're going to do 2 seconds of yellow for the left turns and 3 seconds for the throughs. Ooh, not 23. And red clearance is going to be, you're not going to include it for the left turns, and it's going to be 2 seconds for the throughs. So you have essentially the signal timings done. You have to choose a startup. The startup will depend on what movement you actually want to have start your signal or your cycle or even your simulation. Generally in practice, people will simulate for a couple minutes, like 15 minutes, and then start recording the data. If you do that, it doesn't really matter which signal group starts the cycle. But for this example, we are going to choose 4 and 8, such that we start our signals with the westbound through and the eastbound through. Now we are going to check minimum recall for all of them. And dual entry for all of them. You may be wondering right now, what is min recall? What is max recall? The minimum recall is the minimum amount of time that the signal at the intersection will give to the vehicles on the road. So even if there is no demand detected, it will give the minimum amount. So how do you detect demand? Usually there are detectors actually installed in the pavement that can detect the vehicles passing by. If these detectors detect a certain volume of cars, then it will change the kind of recall that will be used. It will give either more or less time. So what minimum recall does is, even though maybe it does not detect any vehicles or only detects very few vehicles, it will still give at least 35 seconds for the through movements. So that's minimum recall. Maximum recall is when the detector detects a lot of demand. When there are so many vehicles that the controller has to do a continuous call for vehicle service on the phase. And this means that it will present the green through signal at the maximum amount of time allowed. So because I don't actually designate a max for the signal timing, you can't really choose the difference between min and max recall. But in your assignment, you will have a signal timing card that kind of looks like this for Columbia Street and Westmount Street, where you will have min, max, and extensions. So if you put in all the information according to this, so let's look at the east-west green arrow. That would mean that if I were to copy this signal timing into this signal controller right now, you would have for the eastbound, westbound green arrows, so that would be movements 3 and 7, I think. 3 and 7? 3 and 7. You would have the numbers 5 in minimum green, 3 in vehicle extension, and 8 in a max 1. And for Westmount Road, you would have a green, and rather than having min green 35, that would be the north-south movement, you would have a min green of 10 seconds, an extension of 3 seconds, and a max of 30 seconds. This can be complicated by indicating that there are detectors on the road. In your assignment, you don't actually have to add detectors. What you can do, though, is change the results of your simulation by choosing minimum recall versus max recall. Because min recall means you give very little time for vehicles to go through and to turn left. Max recall means that every time you get a signal, or in every cycle length, you will be having the max value of green time for your vehicles to go through. That changes your simulation results, and you may be wondering right now, Jessica, how do I choose whether to use min or max recall? Generally, in practice, max recall is used when, in practice, you wouldn't actually add detectors. But let's say you didn't have the detectors, you would be using your judgment to determine if the time that you are simulating has high enough demand to justify max recall, or if you have low volumes, you have low enough volumes to justify min recall. So that's up to you, and how you use that information during your assignment may change your results. So it is best to use your judgment. You can ask me more questions in person during tutorial or whenever. So that's it for the basic signal timing. Not so basic, very complicated, a lot goes behind it. But now that we have included protected left turn signal timings and also labeled everything correctly, we can go down and continue on with preparing our signal timing in Vism. We can scroll down and go to pattern 1 and press our splits. So the split is essentially how much time is allocated in each cycle to a specific movement, including the yellow and the red time. So in the case of signal group 2, or just all the 3 movements, it'd be 35 plus 3 plus 2. So for all the even numbers, this is why in practice you label the through movements even numbers and the left turns odd, because then it makes it very easy to remember which movement is what. So for your through movements, the even numbers, you will click 40 for the split. 40, 40. And the transition max will update automatically. So for your left turns, it's also the sum of your min green and your yellow. And it will automatically update with something else. So 3 plus 2 is 5 for each of these. Okay. Now, this, so setting these numbers in pattern 1 is actually optional, but you know what? Just do it. You're following this along already. Next, we can scroll down to schedule and sequence. So in schedule, right now, it says free under pattern number. Make sure you change the pattern to 1. Pattern start time is 0. You can keep that. Next is sequence. Sequence is what it sounds like. It's a sequence in which your signal groups will actually be activated, so when they turn green. What you want to type in here is the fun part. Because of the way you actually formatted your intersection at the beginning in your signal timing card, you can just type in 1, 2, 3, 4, 5, 6, 7, 8. And since this is a simple network, no other settings are used. You can always add detectors, but that's more complicated and not necessary for this assignment. So we have done this, we're good, and we can click away. An important step to not forget under sequence is go a little bit above, essentially like where you can see the add minus slash. Remember to add thick lines in between this so it will actually differentiate between your eastbound, westbound movements and your northbound, southbound throughs. So after you do all this in the signal timing card, you will be able to go into pattern 1 and you can type in the cycle length. So the cycle length is essentially all the min green times with all the yellows added with all the red clearance. So in total, for one group of directions. So the cycle length is actually the northbound, southbound, and the eastbound, westbound. So that would be 3 plus 35. So 3 for the northbound, southbound, it would be 3 plus 2 plus 35 plus 3 plus 2 plus 35 plus 3 plus 2 plus 3 plus 2. So that's 90. And that's going to be the cycle length for each. And it's a start. Yeah. And now this will pop up. It will have your cycle lengths, and you can just kind of look at it. Can you drag it around? Yeah, you can. Don't do that because that just shortened that. Make sure it's 40 seconds. And you can continue on. You can also scale it as required. Your signal diagram may update to a scale that is too small. Right-click on the signal diagram, which is this part. Right-click, and you can resize to fit the screen. Now, you've done it. You've made a signal. You've entered your signal timing into Vism. You want to save it. So, click OK. And you can name it whatever you want. It's really good practice to make sure that you name it the intersection it is and the time of day, because you might be doing different times of day throughout your project. So I'm going to assume this is the morning. observation time. If you're doing the afternoon one, call it PM. So morning, AM. And we will save. Make sure you save it in the same file as your Vism file. That should make your life a little bit easier. Okay, so you've made a signal controller, you've inputted the signal timings. You can press OK. Now, you need to actually add, now the next step is to add the signal heads, and the best way to do this is to put the signal lines, so signal heads, insert mode, and you're going to put it where people stop, look at the signal light, and then make a decision. So let's say you are driving down Ottawa Street and you get your signal and you see a red light. You would stop at the stop bar. And that's the same with a left turn. Where's the stop bar on the left turn? So if you zoom in, you can just kind of put a signal head about where the stop bar is. You should go on Google Maps and double check the location of the stop bar. But I have put in a signal head, and this is for the eastbound through movement. So we have named our signal groups according to this diagram. So that is going to be in, so the eastbound through is movement 8, and this should be in signal group 1. So we're going to find signal in SC and signal group 8, because that's what we designated the eastbound through as. So we click OK. Then you do the same. This one's the same. It's also 8. Okay. And now we have our westbound through. Westbound through is 4. One interesting pattern I noticed is that for each of the opposite directions, so eastbound versus westbound, it's 4 away. So if we go and do the northbound through, we know that it's 6. 1, 6. 1, 6. It would be the one that's 4 away. So it should be 1, 2. And we can check that. So it's 6 for the through, northbound through. Wow, it is 2. It's 4 away from whatever we're looking at. And this is why it's actually pretty convenient to follow the Federal Highway Association labeling convention. It just makes things so easy. It's a little bit difficult to remember in the first place, but if you just have this handy somewhere, you're fine. So, I don't know. Print this out, save it, post it on your bedroom wall and look at it every day. Admire it. Do what you want. But in Vism, you can't do what you want. You have to do what the Federal Highway Association wants. So, southbound throughs. Signal timing group 2. Ooh, forgot something. It's 2. Okay, so, signal controller? No. What you should also do is name it so you actually know what direction everything is going. That would be very good convention. But I forgot, so sorry. Now, let's go through our left turns. So it's the same. Go to where approximately people would stop for left turns and assign it the correct signal group number. So a eastbound left is a 3. Northbound left is a 1. Westbound left. Make sure it's on the right link. No, that's wrong. Is a 7. I think you can move it up a little bit, yeah. And Southbound left is a 5. Okay. Now, you may be wondering, Jessica, what about right turns? When you think about when you drive and you have a green light for your through, what would you do? And you have to turn right. What would you do? You would just turn right because you don't actually have anything conflicting other than a potential left turn that's trying to also leave on the green. So what you do is you just treat the right turns as a stop sign. There is no designated right turn signal. So to do this, you go to stop sign and you add a stop sign wherever you think it should go. And this is generally connected to the signal group of the through movement. So the northbound, originally it was going northbound, but it is now going east. Is that east? Yeah, east. You would give that 6. And that should correspond with the through movement signal head. So I gave it 6, yep. And you just do that. And that's a 4, so you should give a 4. That's a 4. And this is a 2. You coordinate the stop sign with a 2. And you do the same for here. That's an 8. That goes with the 8. Because that essentially shows you when the right turning vehicles can actually go. So now you have all the stop signs, you have all the signal heads. Signal heads are designated as the dark red lines. Stop signs are the orange lines. And you have it set correctly. One important note when doing your through lanes, because you also have right turn lanes, the signal timing might, Vism might get a little bit confused what you decide to put as the signal head. So Vism might get a little bit confused when you put down the signal head if you put it too close to the right turn. So let's say I moved this signal timing back. Vism will consider this a signal head for the right turn. So in order to fix this, move the signal head after the right turn. Make sure you do that for all of the through movements that might conflict with a right turn. And once you have finished defining all the signals and putting in the stop signs and configuring where all the stop signs should be, you can save it and you can press play, the play button up here, and it will start simulating traffic. And this is the fruit of your work. Cars not running into each other. Yeah, so this was an extremely long video, but I hope it helps. Please let me know if you have any questions about the material in person or through email. And in part 7, the next video, we are going to be talking about collecting results from Vism.